Hey everyone. So today I'm here to talk about why should we care about the plan cache. And for this talk, I like to do sort of a quick level set. There's not a large demo component to this talk, and I'm not going to do a super technical deep dive into the ins and outs of the plan cache. I am actually literally going to kind of talk about why should we care about this? Why is this important? And a large part of that is because I think it's one of those features that can be kind of intimidating when you first look at how to use it. But there's so much value to be had here that I think it's beneficial for everybody to be motivated to understand what it does and how it can help you. So where I'm coming from this talk is here's how I think. So I believe if you go to your typical performance tuning presentation or pre-con, I think it's very easy to walk out of the session with the idea that this is kind of how things work. So let's say I'm at the office, hunched over a keyboard, working hard, and in Teams, Smith from the security department pops up and says, hey, Rick, the server sucks today. What did you do to it? Just nothing's working right. Okay, it seems fine to me, but my workload's not your workload. I'm doing something different. Specifically, what query are you running? And then many of us would like to believe that what happens next is that Smith copies and pastes the exact query in a messenger and says, well, as always, I'm very interested in the career of Mr. Anderson. And by the way, I did promise I'm not going to get super deep. For those of you who are not all that interested in talking about query plans, bear with me for about 3 slides, and I'll pivot back to the high-level discussion. But to kind of motivate this conversation, I'll go ahead and work through this. Okay, so we've been to our query tuning class and say, I know what to do with this query. I'll copy and paste it from Messenger directly into Management Studio. And you might get something like this. And of course, as we've been told at the conferences or SQL Saturdays that we went to, Management Studio has this really awesome show actual query plan button that we can hit. And of course, we've been taught that the actual execution plan, and I shouldn't say taught like it's not true, we know that the actual execution plan, when you can get it, is much better than estimated. So we hit that button for this query and run it. And what comes back? We might see something like this.
Hey, Rick, real quick. I'm so sorry. We do not see your screen. Do you mind?
Oh, gosh.
I'm sorry.
Thanks for telling me. I'll back up and restart.
Okay. Sorry, folks. I'm going to go away again.
Okay. So you missed this awesome visual when the screen wasn't sharing. And so again, where I was with this was, Smith from security pops up, says, hey, Rick, the server sucks today. Oh, hey, the server seems fine to me, Retro Rick is saying. Specifically, what are you doing? And then he coughs up the query that he is not happy with. Okay, so I copy and paste it in Management Studio. It looks something like this. And in that red circle shows the handy dandy show me the actual execution plan button. Because of course we know that actual execution plans are better than estimated because they have more information in them, which is a good thing. This is not a presentation on reading execution plans or tuning from them. But every time I show one of these, I do like to warn you, take the percentages you'll see in plans with a grain of salt. These are always the estimated costs. Even in an actual plan, they don't tell you they don't necessarily tell you where the time was actually spent. But in this case, it's actually right. These estimates are good. We actually really are spending like 99% of the time doing a key lookup. So what is this plan telling us? High level, we see we're doing an index seek to satisfy the query. That's the top operator there. And then there's a key lookup operator below it. In English, what that means is that there's an index that helps us find Mr. Anderson's record. But it doesn't give us all the information we need. There's some more information the SQL Server needs to really fully satisfy Agent Smith's query, and that's why his query is running so slow. And again, with the technical skills we've picked up at previous conferences and how to tune this stuff, we know we can right-click on key lookup. Well, we can hover on key lookup if we want to, but it's better to right-click on it, select properties, and we'll find a window like this, which, finally, four slides later, has told us that the reason this query is running so long is we're having to go back to the table itself to get the title column to satisfy the query. So I think I know what we do now. I'll hop back into Teams and say, I think I see what the issue is, but I'm not convinced that this particular query ever performed well. Is there any chance that before today you weren't actually asking for the title? Oh, yeah. Yeah, Rick, you're right. This is the first time I actually asked for the title. It's like 4 characters of text. I really didn't think it would rock SQL Server's world, but yeah, that is new today. My bad. Well, and of course the response to this point is, cool, I see the problem, I fixed it in production, and you should be good to go right now, right? No, that's not what we say. Okay, maybe just what we say. It's not what we're supposed to say. The correct answer is, of course, I see the problem, I have a fix that I like, I've applied it to the test server and put it kicked over the wall to the QA. The fix should be in production in like 3 months, because we don't want to just go through and change stuff on production willy-nilly. So again, that is how we might get the idea that things should work. And when I say that, it's not meant as a knock on people, well, frankly, like myself, who like to go around and talk about performance tuning topics and give pre-cons at conferences about performance tuning. The issue is really more when we're talking specifically about this stuff, time-wise, typically our hands will be pretty full of just talking through the technical skills that you'll need to do various things to tune performance. We don't necessarily have a lot of time to talk about why you use different tools or why there are 3 or 4 different ways to do things. So where I'm coming from with this talk is I believe client cache is important because this is more likely to be our realistic experience. I'm at home in a bathrobe, slacking off on Facebook. Don't worry, the bathrobe's not weird like everyone else has been. I'm working from home. Smith pops up and says, hey, Rick, the server sucks today. Oh, okay, it's fine for me, but my workload's not your workload. Specifically, what query is it that you're running? In real life, the response is more likely to be, dude, I don't know. I don't know that I ever understand a freaking word you say, but this time especially, I think you stopped speaking English like 5 minutes ago. I was in the app on our company intranet. I clicked a button, nothing happened, and I was kind of told to pick up the phone and give you a call. So fix it. So I actually believe it's oftentimes a little bit worse than even the scenario I just laid out. It's entirely possible that users won't necessarily so in this particular case, something bad was happening on the server at that time. Somebody got the attention of the DBA and asked them for help. More often than not, there's a good chance that it's going to be after the fact. So it's entirely possible someone might come up to me and say, hey, I was doing something on the server that was kind of slow yesterday. Because it was slow, I was late to my meeting with the coast, and then I had an upward appraisal meeting right after that, and then it's 5 o'clock, so I went home and had dinner and slept. I frankly don't really remember what I was doing yesterday, but whatever it is, I'm pretty sure SQL Server was slow. So, can you figure it out and fix it, please? Okay, yeah, but maybe that's not the case. We might get lucky. It's entirely possible someone actually is doing something right then that they know is slow, which is good, but that's where we get back to the Agent Smith example I just walked through. I shouldn't say none of us work in environments like this, because there's always 1 or 2 weird exceptions, but for the most part, we don't work in environments where we have hundreds of people hunched over keyboards typing SQL queries all day long at the office. In reality, the real consumer of our database servers is almost always software. So not only do we not actually have a user typing in a specific query that they care about, they usually don't even see what the query text is or even necessarily know that something called SQL is involved in the process. Okay, so at this point, it's tempting to say, that's fine. In a way, that could be good news. The software is a real consumer of our database system, so I'll just go find the software document that I'm sure the development team produces and look up what queries it's executing. And in a way, that should almost be more precise than talking to the end user. The problem is you're not likely to find the documentation. And full disclosure, I used to be a developer, so I say that mostly because I'm trying to make the point that I'm not trying to pick on developers to say that we do bad documentation. More where I'm coming from is detailed software documentation typically does need involvement from the developer staff. And every hour the developer spends working in documentation is an hour that they do not spend doing something that directly generates revenue for the company. It's not to say that we shouldn't do documentation or we don't do documentation. It does get done all the time. It's just there's a cost-benefit trade-off involved in how much detail goes in the software document. And the trade-off in most organizations does not come down on the side of actually listing every single SQL query that could be issued by the software system in the document. But, we could get lucky. Maybe we had that one eager beaver developer who's decided, I'm very excited about this new job. I'm very excited about this new feature. I'm going to write the best software document ever. It will be the software document by which all future software documentation is judged. The problem with that is software changes over time. And a lot of our organizations that have weekly or quarterly, weekly, or possibly even daily releases to the code. If the documentation is time-consuming to create, it's also fairly time-consuming to keep up to date, which is a long way of saying that even if the documentation did get down to the level of specific SQL queries, the odds are it's not up to date anymore just because stuff has changed. Okay, fine. You're trying very hard to depress us, Rick, but still, somebody wrote the software. I'll just go down the hall and talk to the developers and ask them, what are you doing to my database server? So there's at least two issues you run into there. The first one is just like on the IT side, where we tend to have fairly high turnover and people tend to job hop more often than they might in other industries. It's just as bad or worse on the development side. So if something's been in the code for a year or two, it's entirely possible that the person who wrote that code isn't there anymore. The other catch with this is, again, I used to write code back in the day. So I can say from experience that there really is something about it. Software development languages are kind of weird. They're abstract. They don't have a tendency to stick in your head. So even if you can track down the person who wrote a specific line of code, if it's been more than 2 or 3 weeks, there's actually an old saying in the industry that anything that's written more than a month ago may as well have been written by someone else. It's kind of true. Even if you can track down the person, the odds are they're not going to remember exactly what the code did without doing some research. But it's actually worse than that. Even if you find someone who does remember the relevant line of code and they can go directly to it, it's entirely possible that there's not actually a SQL query there. Or another way of saying this is that the actual query issued by the software may vary depending on what parameters are passed in. But what does that mean? So obviously the most, the clearest example of this would be something like link to entities or Hibernate or some other object relational mapper where, it's basically a query generator, and the query that gets spit out depends on what the code is doing right at that point. But that doesn't necessarily have to be the case. You can have this in T-SQL also. For example, a lot of software projects that display data, reporting type applications that display data to the user, will have a tendency to have a bunch of columns running down the screen, and over each column will be a little text box where you can enter a filter condition. And the idea is that any arbitrary combination of filter conditions should give you a response, and ideally a fast response. That's a pattern that comes up a lot, and it's actually a pattern that is usually not possible to do efficiently. There is a way to do it without doing dynamic SQL, but it's very hard to do efficiently without doing dynamic SQL. So even if 100% of the queries in your system are coming through T-SQL, instead of through something like link to entities, there's still a very good chance you're going to have dynamic SQL. So you can't know just from looking at the code exactly what the query looked like. Okay, so that's fine. We might say, I understand the problem. I'll just explain to the end users that, you know, I'm waiting for a response from software. So backing up a little bit, the point I'm trying to make with the previous slide was not that it's not legitimate to walk down the hallway, talk to the development team, and ask them what query is hitting the system. The point I'm more trying to make is it's not going to be an instantaneous answer. There's a good chance it's going to be a research project, and it might take a few days for them to be able to figure it out. And during those few days, this possibly might have stakeholders lining up outside your office with pitchforks and torches because they aren't really going to understand what the issue is as well as we might. They're just going to know that the database server that, you know, we're responsible for, or perceived as being responsible for as the DBA isn't working right. And yeah, they get lots of counterproductive suggestions. I won't really go through this in detail, but you know, things to the effect of specifically what resource is the server short on. You know, can I just write you a check and send you to Best Buy and you can buy more of whatever you need? Yeah, it's not that easy always. The one in the middle I like to mention just in case you haven't tried it. Just index every column. If you haven't tried this yet, I'll save you some trouble and don't try it. In reality, this almost never helps. The most obvious problem is adding indexes may help select statements, but it slows down inserts, updates, and deletes. But the bigger issue with this is because of the way the optimizer works, and this going deeper into this is out of scope for this talk, but because of the way the optimizer works, SQL Server has a tendency to not really use single column indexes. So if you have 20 indexes, only have one column on your table, it's typically going to get ignored by the optimizer. And the ever popular, you know, back when I first started giving this talk, it was, you know, so I've been talking to my nephew about MongoDB. Now it's more like I was playing golf and, you know, a friend on the golf course mentioned Redshift. Have we looked at that yet? So I know some of us have gone back to work and no longer working at home. You may be listening to my office and you may be getting dirty looks from people in other cubicles because it sounds like I'm saying that they're stupid. This is not what I'm saying at all. It's actually the contrary. So those of us attending SQL Trail have probably all spent a large amount of time getting to be really, really, really good at doing something with SQL Server specifically. The people that we work with have all gotten to be really, really good doing something not SQL Server. So of course it's SQL Server, and especially, you know, kind of the obscure performance topics we might get into just isn't their area of expertise. But I actually feel it's worse than that. We are, so I think a lot of us, I think a great example of the problem is, I don't have it with me. I usually carry around the visual aid, one of the old iPod classics. You know, the old school Apple iPod that had the display screen to show you what song was playing and this weird little wheelie interface in the center that most people found very, very intuitive. I never quite got the hang of it, but for a normal person, it is a very, very intuitive, but very, very simple interface. We've kind of gotten used to that. We're surrounded by electronic gadgets that actually do quite complicated jobs, but only have 2 or 3 buttons, or increasingly may not have buttons at all and just have a voice interface. In the database world specifically, I argue it's actually even worse than this. I think our users in some ways are thinking of the database the same way that we might think about a car, even though it's a very different kind of thing. So let me unpack the example a little bit. Let's say that we're driving home from work one day, stop at the grocery store to get a gallon of milk on the way home. And after we come out of the store and start driving home, the car just isn't acting right. It might keep trying to stall. It won't go faster than 20 miles an hour. It's technically functioning, but it's just not running right. What we do succeed in limping it home, don't actually have to call a tow truck. And the next day we take it into the shop, and imagine having the following conversation with the mechanic. Yeah, it's the weirdest thing. So I was at work, kind of a long day, but I decided to stop on the way home, go to the grocery store, picked up some milk, got back in the car, and it just wouldn't go after that. Strangest thing. Can you check it out and see what's wrong? The mechanic might come back with, so you stopped at the store on the way home. Yeah. Came out with some milk. Oh, yes, I did. Well, that was your problem. I can see you're not following. Okay, I'll try to explain this again. So you see, last time you brought your car in to have a tune-up, you told me that you drive between your apartment and your office. So I gave you a tune-up to do precisely that, to take you safely and efficiently between your home and your office space. At the point where you deviated from that plan, recklessly took the different exit from the freeway and went to the grocery store, it's just kind of dumb luck that your car didn't break down. You just happened to be doing a workload that was coincidentally similar to the normal driving that you do. But at the point where you went into the store, got an unauthorized gallon of milk, and added it to the workload of your car's passenger cabin, you just completely broke your performance contract with me. I'm not saying that you can't buy milk. It's just, if you are going to decide to buy milk on the way home, talk to me first, and I'll give your car a different kind of tune-up that will adequately support adding the milk to the passenger compartment. Of course, it's not a realistic conversation. We would never have a conversation about a car with a mechanic, but in my mind, when we're talking to a stakeholder at the office and we're trying to explain to them that by modifying one of the queries, they broke one of recovering indexes, for example, I think that's exactly what we tend to sound like in their mind. So why does this matter? I think really the key point here is people are going to kind of think about the database server like it's a car. In other words, a car is obviously, especially nowadays, a super complicated piece of technology. There's lots of moving parts. There's a computer system. There's software. Nowadays, they even do software updates on your wireless at home. Probably hundreds of parts, lots of systems. It's entirely possible that the cars have gotten complex enough that there aren't really people out there anymore who necessarily understand what every part, what every component does in detail. That said, at the end of the day, if you get behind the driver's wheel of a car, point it in a specific direction and hit the gas pedal, it goes, and it goes predictably, and you can control it. In other words, all those really complex things kind of come together in a simple sort of linear system that we can optimize in a straightforward way. The problem that we have as database people, and especially in the performance tuning side, is databases are not like that. They're not linear. The workflow hitting the database can vary from one point in the day to another. And even over time, as you add rows to tables, even if the workload is the same, the performance characteristics can change, and they're not necessarily going to change predictably. And it's also not likely that there's going to be one specific resource that you're short on. It's entirely possible that at different points of the day, at different points in the business cycle, there might be different bottlenecks on your database server. Oh gosh, so that means we're doomed, right? I mean, so at some extent, it sounds like when I say users see our database the same way we might see a car, to some extent, it sounds like I'm saying our users think all queries are kind of equal and that we can do one thing that's going to make all the queries in the system better. And the bad news is that that's just not true. Most of our databases do different kinds of things, different kinds of tuning are going to be appropriate for different queries. I turn that around though. I say it's actually, in a way, good news. Not all queries are equal. In other words, even if we feel like we're getting pressure to make everything faster, the reality is no matter how much time we spend doing performance tuning operations, the impact of performance tuning is only noticeable for queries that waste a lot of resources. Because to see a reduction in resource usage, that actually means we have to reduce the resource use. If a query wastes a lot of resource, it also means it uses a lot of resource. So even though the expectation that we make everything faster is actually completely unreasonable, the good news is if we can just find out what is using the most resource in our system and focus on those, even if we can't really get good information from the end users about what specifically isn't working well for them, we can still look like we're making everything faster and kind of look like miracle workers in a way. So what kind of thing would we like to see here? You know, what magic performance monitoring tool am I proposing? So the things we would like to see. We obviously need something that keeps track of the queries that are run on the system. And we need something that keeps track of what resources are used by those queries. And I do mean resources, plural. On the database side, we have a tendency to think everything is an I/O problem, because typically most database systems historically have been I/O bound. That's maybe less true than it used to be with flash storage becoming more common, but again, that's literally another talk. But the point is, we're not always going to find a database server is I/O bound. For example, I've been in situations, one specific situation is coming to mind where someone else decided to help us out by installing a system performance monitoring tool on all the servers, including the database server, without configuring it. And we came in the next day, and the database server was pegged at 100% CPU usage. I may not normally track CPU usage that closely, as closely as I/O usage, but that day specifically, I cared very, very, very much about CPU usage. And there's similar things. There might be days where you care more about how many cores something is using, how much I/O it's doing, possibly even how much time it's spending in the common language runtime. But we also need to be sure that this information is aggregated across a lot of runs instead of looking at one specific query. The reason for that is if we have a query that runs for 2 or 3 hours, it's kind of a ridiculous amount of time, but say that it did run for that long. Obviously, we care a lot about trying to make that query faster. If we have a query that runs for half a second, do we care about that? It depends. If it runs for half a second once a day, we probably don't care. But if it runs for half a second and it's run every 2 seconds, we care about that. In other words, we want to know how much time it's used in the aggregate across a long period of time. Ideally, we would like to have something that gets us query plans also, without having to do extra work for it. And we want something that's running all the time. What do I mean by that? Well, this is going to date me a little bit, but if we back away from performance monitoring and talk about deadlocks for a second, there was a time where in SQL Server, so nowadays, for almost all of us should be in a recent version of SQL Server that we can just go into the system health extended event session, see all the deadlocks on our system and get deadlock graphs, and it's easy. It wasn't always like that. There was a time where SQL Server did not track deadlock information by default. So if we were told that code was deadlocking, we couldn't just pull the deadlock graph. We would have to go into SQL Server, turn on some trace flags. Depending on how you like to turn on trace flags, a lot of people thought they'd have to bounce the SQL Server instance to make it happen. So they would bounce the SQL Server instance because nobody cares if we do that, in the middle of the day while the business is running. But at that point, we're not done. We still did not have our deadlock graph. We had to actually wait for it to happen again, which puts you in this weird situation of, hoping for a failure so you can analyze it. And then once that happened, we finally have the deadlock information. We don't want that. We don't want something we have to turn on after the fact. We want something we can look at and it'll just be there for us. And this last one is not a dig at extended events. We would really like to do it without having something like an extended event. I personally love extended events. I use them constantly. But I have noticed if I get in front of a group of DBAs and say something like, Profiler has been deprecated for like 10 years now, we should all get on board with extended events and stop using Profiler, people throw stuff at me. Extended events are hard to set up, still hard to set up because they don't really have fantastic tooling. It's a lot better than it used to be, but it's still not at the level Profiler was. Even when you get them, they're kind of big, they're blobby, they're XML, so it's really text heavy, but it's hard to read. So you usually end up having to shred it, and database servers just weren't meant to shred XML on the fly. Even though SQL Server can do it, it's not fun and it feels like a waste of CPU. We'd like to have something that wasn't like that. Well, the good news is everybody's SQL Server does this out of the box without having to turn anything on. Incidentally, even without having to turn on query store. And yes, I do need to get out more. These are my best friends. But really, what I'm going to be talking about today, to give you an idea of how to get this information out of your system, I'm really mostly going to be talking about 3 dynamic management objects. There's a dynamic management view called sys.dmexec query stats. And yes, these names are horrible. That's, again, part of the reason for this talk. If we start seeing these names and see the horrible queries that we make by stringing these together, the people will gouge their eyes out. This talk is really motivation to slog through this stuff. So back to the slide. Sys.dmexec query stats gives us lots of info about the query, and I mean a lot. There's the time the query is created. In other words, the first time it was run and added to the cache. The most recent time it was run, how many times it's run, how much in terms of min, max, and total CPU it's used, how much time has elapsed, how much I/O it's done. So actually, if we hop over to, I'll hold off on doing that because I'm not showing the entire screen. But yeah, there's all kinds of things in there. It even contains query grant information. Recent versions of SQL Server, you have query grant information. So if you have memory being used but don't know where it's going, you can find it in this query in the plan cache. How many CPUs something's used, how much time is spent in the common language runtime if you're unfortunate enough to have CLR store procedures in your system. Absolutely positively everything you might want to know about the queries I've run on your system recently, except for what the query actually was. I thought that was weird when I first heard it. I've made my peace with that fact by thinking about it this way. All the things I just listed off when I was talking about query stats, number of times something is run, what time it was when it ran, how many pages it's read, all those things are kind of fixed size, integer sorts of things. We talk about what the query itself was. I mean, the query is kind of big, it's blobby, it's this massive piece of text. The storage needs of those two things are completely different. And in addition to that, there actually is not necessarily a one-to-one correlation between a query as a stored in a query stats and the query text that the user typed in. It's actually possible for the same query text to look like different queries if the session settings are different. We might talk a little bit more about that later. Just putting it out there that the mapping isn't always the same. Okay, great. So we have our buffet of performance information about the query. We have a function that we can call to get the text for the query. I know we usually say functions are bad. This function is okay because it's filled in or something. No, that's the way that we call it. This particular function is not the kind of thing we usually worry about when we say functions are evil. But I promised you execution plans, and I haven't delivered on that yet because the execution plans are not in the query stats view either. Well, there's another function we can call. So we take sys.dmexec query plan, pass in a handle that we get from query stats, and we can get the estimated execution plan. And again, we haven't had to turn on anything to get these things working. In terms of requirements, not a heavy lift nowadays. Need SQL Server 2005 or later. If you're still running on something older than SQL Server 2005, I'm sorry. I'm not very sorry they can't use this feature. I'm just kind of sorry in general. Things were painful back then. I remember. Now, there are a couple of columns that were added. If you have a really, really heavy ad hoc workload, in other words, if you don't have parameterized SQL, if it's all been expanded and you have each query only hitting once, there were a couple of columns that were added called the query hash and the query plan hash column. They're added in SQL Server 2008. Again, that's not a big ask nowadays. Most of us are on something more recent. And if you are unfortunate enough to work in an organization with competent security people and you don't automatically have SA permission everywhere, the appropriate permission they need for this stuff is the view server state permission. As the slide says, don't write this down. This is kind of a sample of the kind of query that we can use to pull information out of the plan cache. Why do I say don't write this down? Well, I mean, part of it is if you like the specific query, feel free to email me if you want my specific bits, and I can respond with it. But more to the point, lots and lots of people have blogged about how to get information out of the plan cache, and everybody really has substantially the same query for doing this. So even bloggers that I would not necessarily recommend looking at are fine for this stuff. It's really kind of always the same query. And which really is another way of saying that you can open up, Google or your favorite web browser, just search for SQL Server expensive queries, and you're likely to get something very, very much like what was on the previous slide. Okay. So breaking it down a little bit. When we look at this, for the first time, there's, we will make a face, wince, and our first thought is, wow, that select clause is just horrible. It's actually so big I couldn't copy and paste it onto the coming slide. But I actually say it's not as bad as it tends to look. So there's a few things going on. There's a substring statement. There's going back again. The first 4 lines on here are a giant substring statement. Of all the things I'm going to talk about today, that is the one part I would say, if you're new to this, you should feel comfortable treating it as a black box and not worrying about. At a high level, what's happening here is that if you just pull the text, so if you're ideally on our systems, almost everything is coming in through a stored procedure. If you're fortunate enough that that's true in your environment, if you pull the SQL text for a query, it's going to come back with the entire query procedure statement instead of just the when statement that's being tracked. And the substring is basically just taking some offsets that are stored in query stats to pull out the one statement that applies. Okay, so that's ugly, but we kind of get what it's doing. Really, most of the rest of it are just basically goodies. So the reason the select clause is so long is because we're getting a lot of information. We're getting the last execution time, how many times it's run, the first time it ran. We're getting total min and max worker time. Worker time is just another name for CPU time. We're getting total min and max elapsed time. Elapsed time is wall clock time. How long did it actually run? Total min and max reads and writes. And the very, very last part, just the query plan, which will give us our estimated plan that we can look at. Okay, so the select is kind of big, it's kind of ugly, but it's long because we can pull a lot of information out and have it all at our beck and call. It's not long because it's inherently complicated. Cool. Okay, so breaking down this query, what's the next part? Well, the next part are my 3 best friends. We have our sys.dmexec query stats view cross-applied with SQL text and query plan. So to get the text of the query, looking at the second line here, we call cross-apply sys.dmexec SQL text, and we pass in the SQL handle column from the query stats view. That's basically just the information that SQL Server needs to pull up. Think of it like it's it's not exactly good, but think of it sort of as if it was one. The SQL handle just gives SQL Server the primary key to look up the text. And then we cross-apply to exec query plan to pull up the plan handle. Same conversation really. It's just the plan handle is just the key that SQL Server needs to get the estimated plan. And that's kind of all we need to know about the from. Just because I want to have something to talk about, the one thing I can say is cross-apply. If you haven't seen cross-apply before, you tend to see it in the context of functions. If you have seen it before and you think that cross-apply just means you're calling a function, that's maybe 80% true. I'd like to talk about the fact, so if you think about cross-apply as saying, hey, I'm getting ready to call a function, you're not always going to be right, but it's kind of close enough that thinking that is not the worst thing in the world. But in the interest of talking about what's really going on, what cross-apply really means is depends on. So when we have two tables and we have an inner join between them, what we're saying is I have a fully formed and fully existing table on the left, a fully formed table on the right, and I just want to stitch them together. When you see cross-apply, what you're actually saying is I have something on the left that exists, and I have something on the right that is actually going to have to be generated for each row of this thing I have on the left. In other words, what comes out of the function, out of it kind of depends on each row on the left. That's not as inefficient as it sounds. So logically, when you see cross-apply, that means you're supposed to think of it as you're calling the function row by row. Obviously, the SQL Server Optimizer is really, really smart. And if you have an inline function, like all functions should be, it's good about doing it at the record set level, not actually going row by row. But really the point is, yes, when you're calling a table valued function, you typically have a cross-apply involved, but you can also have it with certain kinds of subqueries. If you have a correlated subquery inside that kind of depends on something you've already looked up. And that was probably more than enough time on the from. So there's one last thing in our query, order by. In some ways, I think this is the most interesting part. And I said something that wasn't completely true before. I said that you can pretty much go online, search for SQL Server expensive queries. You'll find a bunch of blog posts, and everybody will have the same query. I'm actually slightly out of step with people here. So typically, if you go on the internet and you get one of these queries, go back to the full query so you can see it. But order by at the end, for most people, will actually be order by total worker time descending. I actually tend to use total elapsed time instead. So why is that? Well, really the reason is I don't care how much CPU the query is used. Okay, don't tell people I said that. Don't tell Carlos I said that. Although he's probably like, I know. No, I don't care how much CPU something is using. I care a little bit. Okay, I do care about CPU. It's very, very important, especially if you're an enterprise edition and you're paying by core. But it's not what I care most about. And some of you might be saying, well, yeah, this is a database server. You don't care about CPU that much because we're always I/O bound, so we care how much I/O something is doing. I don't care how much I/O query does usually. Okay, I do. I care a little, but that's not what I care most about. What I personally care most about is how much time a person who is responsible for signing a check with my name on it had to spend waiting for an answer for the system that I'm taking care of for them. And the best measure of that is total elapsed time. Because even though we don't actually typically have a person sitting behind a keyboard typing the SQL query, they're probably sitting behind a program that's waiting for a response. Okay, and with that, I'm going to go ahead and break to Management Studio for just a little bit. Sorry for the awkward transition. Here we are back in Management Studio. So you should be seeing 3 queries in the window. These are very, very, very similar to the queries that I had in my slide deck. The differences are the select. I made much more modest because we don't need a ton of data coming back. There's only a few columns we care about. And I stuck a where clause on here. The where clause is really just the where clause is because there's not a realistic workload hitting these servers. I generated kind of an artificial workload, but having Management Studio open actually puts a lot of stuff in the query cache. And if you don't have really, really, really heavy workloads hitting it, it can be easy for that to swamp demos like this. So I used a where clause to just clamp it down to one specific database. Two different order bys. So I'm getting, some information ordered by total elapsed time descending, which is my default. And over here, ordered by total logical reads descending. And the reason I'm doing this is to try to make the point that on the last slide I covered, where I said, the order by can be changed around for different situations. This is kind of why. I mean, obviously, a query that sucks has a tendency to kind of suck globally, and it might not matter that much what you order by, but it can. So in this particular case, we have two queries. One of them has run 900 times. One of them has run 10 times. And as we might expect, if we're looking at elapsed time, the one that ran 900 times did indeed take more elapsed time. So if we're looking to reduce the amount of time people have to spend waiting, this might be a good one to look at if there's room for improvement on it. But flipping it around, if we're just looking for overall waste, another thing we can look at is I/O. And the query that only ran 10 times actually did more logical reads than the other query. And if we're curious what the difference is, it's trunking the query. Here's what the difference is. We can actually see it in the execution plan up here. So we pull back the estimated plan. So I'll crack up in the estimated plan. Here, you can see the query text from the plan. Basically doing a select from sales.order lines in the wide orders database for the slot by stock item ID. And we see a beautiful execution plan here. We're doing an index seek because there's an index that supports this query. We're not seeing a key lookup afterwards, so it's not obvious that there's a lot we can do to make this particular query better. So that was the high elapsed time query. So it's using a lot of time just because it's called a lot. There's not necessarily a lot of room for improvement. We look at the high I/O query. Very different situation on the execution plan that we'll come back to, but if we look at the query text, the difference is we're doing a seek by unit price. Unit price does not have a good index on it, so we're doing a clustered index scan. In other words, a full-on table scan each time we call the query. What can we do to improve it? Well, normally if you see a clustered index scan, it means you can use an index. And the cool thing about SQL Server is it even tells us, hey, there's an index here that may help you. Now, don't blindly take these index suggestions. It's, the index suggestions are usually a good start, but they have a tendency to not be 100% what you need. So I like to look at them, see if they make sense, and consider maybe modifying them a little bit before putting them in production. But still, we're getting a really, really good tip on the index. The other point I should make before I go back to the slide deck is I talked about, this horrible I shouldn't say horrible. It's an awesome substring statement in terms of what it does for us. But this horrible looking substring that took up like 4 lines on my slide deck. So here's an example of what it's doing. On the first 2 queries, we just have the substring, and it's pulling out just the query that we're looking for. The reason I put the third query on here is I did 2 parts. I took just the text, unmodified, that we got back from exec SQL text, put it side by side with the substring, and this is where we see the difference, that the purpose of the substring in these queries is we're getting the create procedure if we don't do anything special. So already kind of covered this. I personally do a lot of top 10 lists. My go-to is elapsed time, but if I do care about CPU that day, like if I'm trying to reduce someone's licensing overhead, worker time is a good thing to look at. If we're worried about I/O because we're trying to hold off on having to buy faster spindles, total logical reads and writes make a lot of sense to look at. Interesting corner case, there's a column there called last elapsed time. That's literally just the time from the last time the query ran. Normally that's not super interesting if you have something that runs like 100 times per day. Where it's kind of cool is if you have like a nightly ETL job. If you check the last elapsed time each morning, you can kind of track how long the command is taking each night if you want to trend graph. Things to remember. Not all expensive queries are wasteful. If you do your top 10 list and the top query on the list, as we saw in the demo, actually looks pretty good. You might just have to move on to the next one. Applying cache is not persistent. If you work with someone who likes to bounce a SQL Server service at the first sign of trouble, you probably already have reason to not like them very much. If this is new to you, you have one more reason after this, because nothing I have said in the past hour will help you if the SQL Server service is bounced. This is all memory residence. We're getting the estimated plans out. You remember I said up front that you were better off with the actual plan? Yes, we are much better off with the actual plan if we can get it. Using this technique, we unfortunately just get the estimated plan because we're looking at the aggregate information. In other words, we're not looking at one specific run where we can get the actual row totals for that run. We're looking at a plan that was reused for possibly hundreds or thousands of executions. Different settings can mean different execution plans. In other words, if no, it's just simply that. If any session setting is different, the same text will produce two different execution plans. The reason this matters is SQL Server Management Studio actually has a different set of session settings than pretty much every other method of interacting with SQL Server. So if you've ever had the experience where somebody tells you the query is performing poorly in the software, but they actually have the query and you copy and paste it into Management Studio, like we're talking about the Agent Smith example, and you find it actually behaves well for you, it's possible that that's what's happening, is that you're getting a fresh compile when you put it in Management Studio because the settings are different by default. And you're not necessarily getting the same plan that is stuck in cache that the software is using. And the other reason, so that's one reason that we might not want to copy and paste stuff in Management Studio. The other thing to really keep in mind with this stuff is that any change in a query, so that the hash that SQL Server uses to see if a query matches something in the cache is actually computed before anything is tokenized. In other words, extra spaces and extra capitalization will actually make something look different, and copy and paste can tend to destroy some of that. So all the things I said in that last slide, maybe the most distressing is the fact that we are stuck with the estimated plans. That's not as bad as it sounds, though. You know, obviously we'd rather have the actual plan than the estimated plan because we love to look at actual row counts and see if they match the estimated counts and things like that. But there's still a lot that we can do with the estimated plan. So obviously we can still look for expensive operators in the plan and try to tune those. The other things we can look at that may not be as intuitive, but are still really helpful when we're looking at the estimated plans. Table scans. Anytime I see table scan operator come up in these, I kind of jump on it. But I don't mean table scan as opposed to index seek. Yes, we would normally rather seek than scan, but I actually mean the table scan operator as opposed to the clustered index scan operator. If we see the table scan operator, that means someone's using a heap. Heaps aren't necessarily evil. There are a few cases where they make sense. But if I have something that lands on my desk as a suspected performance issue and I see a heap involved in it, I'm usually going to say this is not one of the times where heap is appropriate and maybe we should get a clustered index on this table. One estimated row count, or with more recent versions of SQL Server, can be 10 or 100. It's not that 1 is a bad number, it's just if it's exactly 1 as opposed to 1.00 something. This is usually a sign that SQL Server does not have a good estimate and it's using 1 out of desperation. When you see that, it's kind of a red flag. You might have a bad plan because you just don't have any realistic row estimate coming in. And it's a good chance to get in and kind of look at why you don't have good information there. Another good thing is In the plan cache, you can order these statements in a stored procedure based on how much time has been spent in them. And you can actually compare that to the percentages that you'll see if you pull up the estimated plan in Management Studio. If those don't match, it's oftentimes a sign that you have something funny happening. In other words, you might have some kind of a cardinality estimation problem if they don't line up, and that's usually a pretty good sign that there's something off in the plan that needs tuning. And my personal favorite, in environments where I'm forced to cope with linked entities being in the mix, if there's a really, really big difference between maximum and minimum values in query stats, and I don't mean 100 or 1,000, I mean I'll actually divide the max by the min and order by that to kind of get a orders of magnitude difference. A lot of times that's kind of a red flag for a parameter sniffing problem. And that's another great place to attack these performance tuning problems. And with that, I think I'm right at the 1 hour mark. So I think while we're waiting, something I keep forgetting to add to this presentation is I'm not necessarily saying that people should do this instead of using a monitoring tool. I think where I'm coming from is, it's good to understand that this is what the monitoring tool is doing behind the scenes. But more importantly, if you work at an organization that doesn't want to, spend on something good, you're not helpless. There's great stuff built into the SQL Server.
Yes. Yeah. I mean, so a lot of times to that vein or to that point, a lot of times we're monitoring production environments, but we may need to get something out of development, right? For example, even our soon to be released podcast, we had last week we were together. We had a listener chime in and said, "Hey, I have this issue in dev, right? And I haven't had it in prod." And so sometimes you can still go back and reapply. And I mean, what's nice to know is always a kind of understanding, the why and what I should be after, right? Because it's inevitably, I mean, sometimes the monitoring tools almost make it worse a little bit because they're trying to show you something, right? This is a problem. And,
yeah.
And so I think I liked your idea of, okay, well, what is it that I care most about, right? Order of operations. Let me do that first, and then we'll go from there.
Thanks, guys. Thanks, Rick.
Thanks, folks.
SQL Data Partners.